Welcome to another fun-filled day on the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability, and we will discuss the answers in a moment. In number 1, we are changing the words to the formulas. And after we complete this section, this topic, then from now on, you will need to be able to do this. So we are practicing all year long. Now the Roman numeral 3 is telling me that iron has a +3 charge. Bromine is -1. The lowest common multiple between 3 and 1 is 3. So I need 1 iron, it is already +3, and 3 bromines in order to get to 0. Compounds must be 0. The Roman numeral 2 is telling me that tin has a +2 charge. Hydroxide is a polyatomic ion with a -1 charge. The lowest common multiple between +2 and 1, -1, is 2. So tin, and I need 2 hydroxides in order to get to 0. Now it is very important to understand, if you have more than 1 of these polyatomic ions, they must be set off in parentheses, because I also have 2 oxygens as well, not just 2 hydrogens. That is an important thing for you to remember. Lithium is +1. Permanganate is -1. Lithium is always +1. It's an alkali metal. And therefore, I don't need a Roman numeral here because it's understood. Lithium permanganate. And the next one, cadmium, has no Roman numeral because cadmium is always +2. It is one of the silly 6. +2. Phosphate is a polyatomic ion with a -3 charge. You'll notice that phosphite, and phosphorus, based on the periodic position, have a -3 charge. So that's a little something to help you remember. So the common multiple between 2 and 3 is 6. Therefore, I must have 3 cadmiums and 2 phosphates. And because I have more than 1 phosphate, they must be set off in parentheses. Silver also doesn't have a Roman numeral. It's always +1. Nitrate is -1. Therefore, it's just AgNO3. Now, hydrogen peroxide is a very special case. Peroxide is a polyatomic ion with a -2 charge, and hydrogen is +2. Hydrogen is +1. I need +2. Therefore, I need 2 hydrogens in order to get that +2 and -2 to be 0. It's just H2O2. Now, peroxide is so special because normally we know that oxygen has a -2 charge for just 1 oxygen. And in peroxide, there are 2 oxygens, and together they have a -2 charge. Therefore, if there are 2 oxygens with a -2, each oxygen has a -1 charge. And that's unusual for oxygen. That's why we use it when we have a cut in order to get the bacteria. We put that bubbly stuff on there, it reacts, the bubbles kill those bacteria. We love the fact that that does that. So that's my hydrogen peroxide. In number 2, we are going from the formula to the name. The first thing I ask myself, is magnesium an alkali metal? No. Is it an alkaline earth metal? Yes. Therefore, I do not need a Roman numeral. It's just magnesium chlorite. That one's not too bad. Now, tin is not an alkali metal, it's not an alkaline earth metal, and it's not one of the silly 6, so I must have a Roman numeral. I look at the negative position. Nitrite is -1. There are 4 of them. Therefore, X minus 4 equals 0 because this is a compound, and therefore tin must be +4. Tin, Roman numeral 4, nitrite. Zinc is one of my silly 6, so I don't need a Roman numeral. It's just zinc hydroxide. Now in D, this is a nonmetal with a nonmetal. So there's 2 ways that I could name it. It could be phosphorus tetrachloride, or the way I would give it to you is with Roman numerals. And chlorine is -1 times 4 is -4. Therefore, phosphorus must be +4. Phosphorus, Roman numeral 4, chloride, or phosphorus tetrachloride. When you use the Greek prefixes, it is for the number of atoms. The Roman numeral is for the charge or the oxidation number of the first element. Again, we have a nonmetal with nonmetal. So I could call it dinitrogen pentaoxide, but that's not the way I'm going to give it to you. So we need to review both ways. Oxygen has a -2 charge. There are 5 of them, which gives me a -10. There are 2 nitrogens and compounds must be 0. In this case, nitrogen is +5. Or dinitrogen pentaoxide. And finally, sodium is an alkali metal, and it's just sodium oxide. Binary compounds take on the ending IDE. And of course, there's some exceptions. Hydroxide is not a binary compound. That's just one that we have to remember. But normally, when we have a compound composed of 2 different elements, the second element will take on the ending IDE. And you've had some practice with that. I think you're getting familiar with that. Now, you are going to have a polyatomic ion quiz that I know that you've been anxiously waiting for. Your facilitator will give you that, and you'll have some time left over when you complete that. It doesn't take very long, and you can begin to work on your review worksheet. Tomorrow, we will go over the review worksheet, and then you'll have an assessment. So please do the review worksheet to the best of your ability, and we'll see you tomorrow. Bye!